What's up, Algebra 1 students? Mr. Ford here with another homework tutorial. This is 5.2.1 Part 2, problems 50 through 54, and away we go. 550, relatively simple. All we got to do is plug some numbers in to a function. Again, this is not meant to be instructional, just merely an answer guide. But I think it's important here that I'm just going to set all of these up because I really want you to see the structure going on here, the bones of each problem, if you will. All these problems are done exactly the same. The only difference is that the number that you plug in is different. Plugging in 1, plugging in, jeez, that's a 9. I apologize for that one. 3 times 9 minus 2. All you're doing is plugging a different number into the function. So they're all done the same way. And all you got to do now is the math. You have to do 3 times the number first, then subtract the 2, then take the square root. This ends up being the square root of 1. This is going to be the square root of 27 minus 2. This is the square root of 6. Oh, that's a 4. What am I doing here? This is a 4. This is 12 minus 2, and this is the square root of 0 minus 2. So the square root of 1 over here in question A, the square root of 1 is 1. That's an easy one. This in part B, this is the square root of 25, which is 5. Nothing to worry about there. Now you have the square root of 10, which honestly I would circle. I'd call it good. The square root of 10, you can ask a calculator what it is. In fact, let's do that right now. Here on the bottom, here, I'll bring it up. The square root of 10 is that number there. If you want to write that decimal down, you go for it, but I think the square root of 10 is the best answer to this question, so I would not do anything else. And you have the square root of negative 2, which is another good one to ask a calculator for, because that one does not exist. There is no answer to this problem. If you ask a calculator what the square root of any negative number is, it will say error, non-real answer. And the reason why is because you cannot take the square root of a negative number. As far as question E goes, that question is a little different. Now we're looking for what input will give you the output of 6. So what do you plug in to the function to get 6 out of it? So we're actually solving this problem. The square root of 3x minus 2 equals 6. What do you have to do to get 6 out of that function? Algebraically, what we would do is we would square both sides. But I think a better way to think about this is to just off to the side think, okay, the square root of what number is going to be 6 itself? In other words, what is 6 times 6? And that is 36. So what you need is 3x minus 2 to be 36, basically is what's coming out here. And that's what happens anyway if you square both sides, because the square and the square root cancel out, so you just get 3x minus 2 equals 36. And from here, it's just a pretty typical algebra problem. You're going to add 2 to both sides, which means there will not be a whole number answer, because 3x equals 38. That will not divide evenly. But if you divide by 3, you get x equals 38 divided by 3, which is the same as, I think, 12 and 2/3. Not that it matters. I like 38 over 3 better anyway. 51 is a really simple problem. All you got to do is see the 1 kind of hiding in front of that y there, and then you want to add those together. You're basically combining like terms here in a weird new kind of way. This is 1.03y. The same thing is true over here in b. That's a 1 minus. So this is going to be 1 minus 0.2 times z, which in this case is 0.8z. And over here, this is a 1x plus 0.002. So it's 1.002x. That's all you're doing there. This is an important preview problem for what's going on in Chapter 5. So keep this one in the back of your mind because we will be doing this a lot with multipliers of exponential functions. 5.552, a tank contains 8,000 liters of water. Each day, half the water in the tank is removed. By how much water will be in the tank at the end of the 4th day and the 8th day? I think this is a good example of a problem that requires a table. Let's have x be the days that have gone by, and this will be the water. And I think what's important is that when we start the problem, we have 8,000 liters of water. So 1, 2, 3, 4, 5, 6, 7, and 8. If you're handy with a calculator, this is the kind of problem you can easily do by setting up a table, but this is good to do by hand. All we're going to do is cut the number of water in half, because half the water is gone every day. So this is 4,000, and then 2,000, and then 1,000, and then 500. So the answer to this is 500. And then we're just going to keep going. Half of 500 is 250. Half of 250 is 125. Now we get into decimal territory. 125 divided by 2 is 62.5. And then that number divided by 2 is 31.25. So that's the 8th day. And there you go. not too tough. A table is an excellent way to reason that problem out. We got some systems of equations in 53, so let's get into it. Let's see. This one, question A is an elimination system, but it's kind of weird because the order isn't quite stacked up. However, you might recognize the y and the negative y. So you can just add everything together in this problem. The y's will cancel out, and 3x plus 5x is 8x. And then negative 10 plus 2 is negative 8. And so from here, you can divide by 8 on both sides, and you get x equals negative 1, and that's that. Well, that's not that. You still have to solve for y, but you can do that. I'm going to use the top equation here, I think, because that's pretty simple. So the top equation is y plus 3 times x equals negative 10. So I'm going to go ahead and plug negative 1 in for x. So this is y minus 3 equals negative 10. And if we add 3 to both sides here, we're going to get y equals negative 7, and that's that. Over here in part B, man, this one is not going to be super fun. Just because this doesn't jump out at me as either a substitution or an elimination system. I'm going to end up using substitution for it, though. The reason why you can't use elimination right away, 6x is on the left and 2y is on the right of the equal sign on the top equation, and x and y are both on the left side of the equal sign in the bottom equation. In order to do the elimination scheme, they have to be on the same side of the equal sign. So elimination, all you would have to do is move some things around. You'd have to add 2y and bring it over to the other side in this top equation, but that's a lot of work. I think the easiest way, what's jumping out at me right now, is this y by itself right there. What I want to do is just subtract 4x from both sides in this bottom equation and make it y equals negative 4x plus 4. And that's not the answer to anything, but I circle it because now I can use substitution. I can replace y with negative 4x plus 4, which is exactly what I'm going to do in that top equation up there. So let's do that. This is probably the most challenging system that we've solved so far, just because it doesn't really give you a bold strategy right away. So 6x equals 7. We got to be really careful here. We're distributing this negative 2, so careful because it is negative. So this is going to become plus 8x minus 8. Looking at that negative 2 times negative 4 and the negative 2 times the positive 4 there. From here, we're going to solve it like we would normally. I think we should combine our like terms first. So 6x equals negative 1 plus 8x, because we have a 7 and a negative 8 there. And then finally, we should subtract 8x from both sides. And man, this, as if this problem wasn't hard enough, we're going to have a fraction answer. Negative 2x equals negative 1, and we'll finally divide by negative 2 on both sides, and we'll get x equals 1/2. Whew, that was a lot of work to get our first answer, but, I mean, it will work. Now we're going to take that 1/2, and we're going to plug it in right here into our solves for y version of the bottom equation. That'll give us y equals negative 4 times 1/2 plus 4. In this case, that is going to be negative 2 plus 4, which is 2. And then I'm just going to quickly spot check and confirm that that works. I know it works in the bottom equation because 4 times 1/2 is 2, and 2 plus 2 is 4. In the top equation, 6 times 1/2 is 3, and 2 times 2 is 4, and 7 minus 4 is actually 3, so it does work. Hey, that's correct. Let's go to the next page here. Draw a slope triangle and use it to find the equation of the line in the graph below. So the slope triangle would look like this right here. Just be careful when you're thinking about your change in y and your change in x. The change in y here is going to be negative 20. I can tell you that it's negative because I know the line is going down to the left there, so it's got a negative slope. The negative 20 comes from the fact that it is going from 150 to 130. And over here on this scale right there, that is a change of negative 20. Because look at the scale, it's going up by tens. Each tick mark is worth 10, and that's 2 tick marks, so that's negative 20. The x is way different, though. That's only going up by 2 here. So doesn't look like it, but that slope is actually going to be negative 20 over 2, which is negative 10 in this problem. There's your slope. The y-intercept appears to be 170. I'm just eyeballing that right there. I'm pretty sure that works. I could, of course, go back 2 more steps and up to 20 more steps, too, just to confirm that it is at 170. So there's that, too. So the equation is going to be y equals negative 10x plus 170, and that is the answer to that question. And finally, the moment you've all been waiting for, the checkpoint question of the chapter. There are actually 2 checkpoints in Chapter 5, so this is 5A, and this is laws of exponents. We've been dancing around this one for a while, and here it is. I'm saying at this point you must master this skill. So the nice thing is none of these are very difficult, so the checkpoint quiz is also relatively simple. But this is the last thing we'll do before spring break. So all we got to do here is simplify. We do not need to write the answer as a final problem, but this first one is going to be 4 to the 7th power. Because all we got to do there is add the 2 and the 5 together. The thinking there is that 4 squared is 4 times 4, and we're multiplying that times 4 to the 5th power, which is 4 times 4 times 4 times 4 times 4 times 4. So that's 7 4s being multiplied together. Just for the record, 4 to the 7th power is 16,384, but you don't need to know that. Who cares? Question B. Now this is the easiest question on the page because 5 to the 0 power is equal to 1. This is 1 to the 3rd power, which is 1. No problems there. You could, of course, ask a calculator about this one. And now we get into variables. We're going to do the same thing with C that we did up above. When we add the exponents together, though, this is going to be x to the negative 2nd power. And one of the rules about this checkpoint quiz is that there are going to be no negative exponents. So we need to deal with that. This becomes 1 over x to the positive 2nd power, and that's how you deal with a negative exponent. This is 1 over x to the 5th times x to the 3rd. You could think about it this way too, like that. And then what happens is you get x to the 3rd over x to the 5th, and 3 of the x's on top cancel out with 3 of the x's on bottom, leaving 2 on the bottom. That's another way to think about the same problem. Question D. Nothing you can really do to combine the x and the y together, but you are multiplying and raising the whole thing to the 3rd power. So we can kind of distribute this 3. We're going to multiply. It's going to be x to the negative 3rd power times y to the 6th power. Again, not to get too explaining on this, but the thinking here is you have x to the negative 1st y squared multiplied by itself 3 times. And what's happening there is you'll get 6 y's and negative 3 x's, essentially. Of course, we're not allowed to have that negative 3 as part of the problem, so we're going to move it to the bottom of the fraction, 1 over x to the 3rd times y to the 6th, and this is better written as y to the 6th divided by x to the 3rd. And then finally, we get our scientific notation problems. These are actually really, really, really simple. All you want to do is take your numbery parts and multiply those together. 8 times 1.6, which is going to be 12.8. Times, we're actually using the x here for times because scientific notation is the way it is. With the tens, you can just use the same exponent rules you always use. Let's just do 5 plus negative 2. This will be 10 to the 3rd power. I like this answer. I'm a fan of it. I like it. Circle it, you get a correct answer. But technically the best correct answer is 1.28. You have to move that decimal point one more spot over, times 10 to the 4th. You know, I'm not really sure how particular Miss Cotton or Mr. Urquhart or any of the science teachers are about this stuff, but technically both those answers are correct. It's just the one on the bottom is the most correct. That's what you'll see in a science textbook or something. Question F is the same kind of game. Just divide your 4 over 5 to get 0.8. And 10 to the 3rd divided by 10 to the 5th becomes 10 to the negative 2nd. And this is the only case today where you are allowed to have a negative exponent. There you go. That's it. That's all I have to say about that problem. Okay, cool. This video came in under 15 minutes, which is great. I will see you in the next video. Don't forget, you are awesome, and you can do this.